Hello friends, so in today's video we will discuss how to find electric field due to electric dipole at any general point. So to understand it, we should know what is the electric field due to electric dipole at axial point and equatorial point. So here you know that if I will take any electric dipole minus q and plus q charge, and you know that the dipole electric dipole moment direction is what? Negative charge to positive charge. If I will take at any point on axial line, let point A1. So here the magnitude of electric field is what? E at point A1 is 2 kp by what? RQ, where R is the distance from the center to the point A1 and K is what? Constant 1 by 4 pi epsilon. P is what? Electric dipole moment. Same way, if I will take minus q and plus q electric dipole, here the dipole moment direction is minus to plus, that is what? P vector. And at any point that is equatorial line, that is on equatorial line, here let at point A2, if I will find electric field due to this dipole, this direction will be opposite direction of what? Electric dipole moment, and its magnitude E at point A2 can be written as Kp by Rq, where R is the distance from the center of electric dipole. Correct? So these are what? Electric field strength at point A1 and A2, where A1 is on axial line and A2 is on equatorial line. So I think so you understood the background of this. And one more thing you should understand here, that electric field strength direction at point A1 is in the direction of electric dipole moment, in the same direction both are. And here electric field strength direction is in the opposite direction of electric dipole moment. Now next is how to find electric field strength due to electric dipole moment at any general point P. So here I will draw electric dipole minus q plus q, okay, and here its direction is from negative to positive charge, that is what P vector. Correct? Now this is minus q and plus q, and I took any general point A, and from the center of this electric dipole it is at distance r and making an angle theta. So what will I do? Here the dipole moment as a vector quantity, I will take its rectangular component. One rectangular component will come along the direction of what? OA. Let this is O, and one is perpendicular to OA. So we will do it. So here if this is making theta angle from here, so one component will come here, that is what? P cos theta, and another component perpendicular to it, rectangular component, that is what? P sin theta. Now we can represent this P vector in its rectangular component. One is what? P cos theta, and one is what? P sin theta. We can understand in another way also, that P cos theta is one dipole and P sin theta is another dipole, and due to P cos theta, whatever the electric field here, that will be in one direction, and due to P sin theta, whatever the electric field here, that will be in another direction, and their resultant will be the electric field strength due to the whole dipole. Are you understanding my point? So first I will find electric field due to the P cos theta. So you know that this P cos theta is acting as a what? Here at point A, if I will find electric field due to this P cos theta, so here this is coming in the line of this. That means here it is in the axial line. So the in axial line the electric field strength is in the direction of dipole moment. So its direction will be in this way. Okay, so this can be written as E axial. E axial, correct? And you know that E axial, how we are writing? Here already we have written formula 2 kp by rq. So here we will write it as a 2k, and because here dipole moment is P cos theta, So we'll write 2k p cos theta, and the distance is r only. So we can write this is as a rq. Correct? Now next one is what? P sine theta. Now you see here, P sine theta and this OA line. This is like as a what? Equatorial point for this. So here you can see, because this is also making 90 degree, and for P sine theta, this is what? Also 90 degree. So at equatorial point, what is the electric field strength? Kp by Rq, where P is what? Dipole moment. So here dipole moment is what? P sine theta. So here it will be what? K E equatorial, you can write E equatorial is what? K, and because dipole moment here P sine theta, here it was P, that's why I have written Kp by Rq. Here it is P sine theta, so I can write Kp sine theta divided by Rq. And because here electric dipole moment direction is just anti-parallel to P vector, here also P sine theta in this direction, so anti-parallel is what? Kp sine theta by Rq. And both are what? At 90 degree angle. E axial in E equatorial making what? 90 degree angle. So we can find E net here. So what is the E net? E net will be root under E axial square plus E equatorial square. E equatorial square. Now it can be written as E axial square, what? 2kp cos theta Rq whole square, 2kp cos theta by Rq whole square, and we can write it as a plus E equatorial means what? Kp sin theta by Rq, Kp sin theta by Rq whole square. Now it can be also written as root under what? Kp cos theta, we'll square it, we can write it as a 4k square p square cos square theta by r to power 6 plus k square p square sin square theta by r to power 6. Here we can take common k square p square by r to power 6, we can take common. So outside it will come k p divided by r to power 3. Okay. Now inside it will remain 4 cos square theta. So 4 cos square theta, 4 cos square theta, correct? And sin square theta. Sin square theta you can write 1 minus cos square theta. So finally we can write it as a Kp by Rq root under 4 cos square theta minus cos square theta is what? 3 cos square theta plus 1. This is what? E net. E net due to electric dipole at any general point. Now you can understand it, if this point will be on equatorial line, then theta will become 90 degree, and you put that theta is 90 degree, then cos 90, you know, this is what? 0. So cos 90 0, this whole term will become 0. So it will be Kp by Rq, and you know that equatorial point it is what? Kp by Rq. So from here we can get this value also. And same way axial point, this theta will become what? 0 degree. So at 0 degree, cos 0 is what? Cos 0 degree is 1. So 3 plus 1, 4. 4 root, it is what? 2. So we can write 2 Kp by Rq, that is coming on axial point. So here axial point EA1 at theta equals to 0 degree. Here theta equals to 0 degree you will get, and here you will get theta equals to 90 degree. So this is the expression for electric field strength of what? This is the expression of electric field strength due to what? Electric dipole at any general point P. You can find E net vector as it is here somewhere, E net vector.